Prep 2. Today we will start our second term. The first unit talks about motion, 2 lessons. First one is called oscillatory motion, and the second one is called wave motion. First, what's meant by motion? It's a change in position. For example, it may be from place to place without repeating, like ball A, from this position to this position. It's called motion. And this is described as transitional motion. But if the motion is repeated, again, if the motion of a body is repeated, it will be called periodic motion. Like this. 1, 2, 3. The motion is repeated at equal periods of time. So it's called periodic motion. And this will be our main point, periodic motion. The first lesson talks about oscillatory motion. But first we have to know what's meant by periodic motion. Motion that is repeated by an object at equal periods of time. For example, when I move my hand like this, the motion is repeated at equal periods of time, or like this. But when I make my hand like this, it's not repeated, it's not periodic. Okay? So simply, any motion that is repeated by an object at equal periods of time, it's called periodic motion. Like what? Like rotary bee, like simple pendulum. When I ask you, give reason, motion of simple pendulum, like this, an object moving. Motion of simple pendulum is an example of periodic motion, simply because it's repeated at equal periods of time. Again, give reason, motion of simple pendulum is an example of periodic motion. Why it's periodic? Because it's repeated at equal periods of time. Periodic motion are 2 types that we are going to study. There are many types of periodic motion, but in our course of the second term, we will talk about only 2 types, which are oscillatory motion, lesson 1, and wave motion, lesson 2. What's meant by oscillatory motion? When can we say that this object has a motion that is described as oscillatory motion? When the motion done by oscillating body around the rest point. When there is a rest point and the object is moving around it. A rest position at which its motion will be ended. Okay? Motion done by oscillating body around the rest point at equal periods of time. For example, I have simple pendulum. When the pendulum moves right and left, at the end of the motion, it will stop right here at B position. So B is rest point, the point at which the oscillating body or moving body stops at the end of its motion. It wants to stop at A or C, it will stop at B. Okay, so B is considered as rest point. Give reason, motion of simple pendulum is an example of oscillatory motion because it's repeated at 2 sides of the rest point at equal periods of time. We have to mention this part at the 2 sides. To say that any motion is oscillatory, it must be repeated at the 2 sides. Forward or backward, right or left, up and down, 2 sides of the rest point. Okay? If this point is the rest point, right and left, it's okay. Forward and backward, it's okay. Or up and down. Examples on oscillatory motion: tuning fork, violin, the strings of violin, they move up and down. And simple pendulum, right and left. Okay? Simple harmonic motion. It's a graph and it's the simplest form of oscillatory motion. The simplest form of oscillatory motion is called simple harmonic motion. Like this, okay? And we will describe this graph accurately later. We have 4 concepts to describe any oscillatory motion. I have 4 main properties or 4 main points to describe any oscillatory motion of any oscillating body that is moving. Amplitude, complete oscillation, periodic time, and the frequency. Four main concepts: amplitude, complete oscillation, periodic time, and the frequency. The first one is amplitude. What's meant by amplitude? If I have hanged object by string and it's moving, when I push it, it will move, but it may move like this or like this. Amplitude means the maximum displacement made by oscillating body away from rest point. This is the rest point, the end point of motion, and the pendulum moved like this. So this distance that the pendulum moved is called amplitude. Again, it's the maximum displacement made by oscillating body away from rest point. Maybe like this, or more. It's called amplitude. For example, I have a simple pendulum that moved from the rest position. Rest position is the red line. The simple pendulum moved away from this place to this place. So the displacement or the amplitude is from here to here. From this place or this point to this point. Okay? On the graph, to measure the amplitude, we have to look at this vertical axis, y-axis. Okay? This is the rest point. And the pendulum moved up for about 6 meters. Not 4 and not more. So the maximum displacement away from rest point is 6 meters only. So when I ask you the amplitude on this graph equals 6 meters. Again, this represents the rest position, position B, that we said previously. Okay? When the pendulum moves from here to here, it reached the maximum displacement, which equals 6 meters. Okay, another example. The pendulum moved from this place at 0 to 3.5. So the amplitude is 3.5 meters. 3.5 meters. Complete oscillation. Motion done by oscillating body when it passes by single point 2 successive times in the same direction. For example, I moved from A in this direction and I return back, and then when I start to move again, it's a complete oscillation. Another example, I moved from B, right, then left, okay, then right again. When I reach the same point at the same direction 2 successive times, it's called complete oscillation, okay, which will be represented by this graph. And again, complete oscillations equals 4 times amplitude. If I have 1 amplitude, I have a quarter of complete oscillation. If I have 2 amplitudes, I have half complete oscillation. If I have 4 successive amplitudes, I have 1 complete oscillation. Again, if I have 4 successive amplitudes, I have 1 complete oscillation. Like what? Amplitude, another, and another. 1 complete oscillation. Again, 1 amplitude, 2, 3, 4, it's 1 complete oscillation. For example, it's 1 round. If I have a graph like this, I want to know the amplitude and how many complete oscillations. First, amplitude equals 5 meters. And to measure the number of complete oscillations easily, we have to put points at the top, points at the bottom, and the points at the intersections. And by counting the distance between every 2 points, that represents 1 amplitude. For example, 1 amplitude, 2, 3, 4, 1 complete oscillation. 1 amplitude, 2, 3, 4, 2 complete oscillations. So the number of complete oscillations equals 2 complete oscillations. How many? 1, 2, 3, 4, 1 complete, 1, 2, 3, 4, 5, 6, 6 complete oscillations. Periodic time, the third concept. The time taken by oscillating body to make 1 complete oscillation. or 4 amplitudes, same meaning. 4 amplitudes means 1 complete oscillation. The time taken to make 1 complete oscillation is called periodic time. And periodic time equals the total time taken by the body over the number of complete oscillations made by this body. If I have a problem like this, if the time taken by an oscillating body to make 20 complete oscillations is 2 minutes. 2 minutes, it's not seconds. 2 minutes, and in our rule, we are using time by unit seconds. Then calculate the periodic time by applying the rule. Time over number of complete oscillation. Time is 2 minutes, and the 2 minutes means 120 seconds. Over 20 complete oscillations equals 6 seconds. Half second to make 1 amplitude. So the periodic time equals 2 seconds. Why? Half second to make 1 amplitude, and to make 1 complete oscillation we need 4 amplitudes. Half, 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 and another half. 1 complete oscillation to make. So the time of amplitude is half second. The periodic time equals 4 times the time of 1 amplitude to reach the time taken to make 1 complete oscillation, which is periodic time. Periodic time equals 4 times half equal 2 seconds. Again, the time on this image is half second that we need to make 1 amplitude. Okay, we need half second to make 1 amplitude. How much time do we need to make 4 amplitudes? 2 seconds. And the 4 amplitudes means 1 complete oscillation. So the periodic time is 2 seconds. On this graph, the amplitude equals half meter, and I have 2 complete oscillations. And the periodic time, the time that we need to make 1 complete oscillation is 4 seconds. The periodic time equals 4 seconds. Why? Because it's the time needed to make 1 complete oscillation. Half complete oscillation, 2 seconds. Complete oscillation, 4 seconds. It's called periodic time. Frequency, the last concept. The number of complete oscillations made by oscillating body in 1 second. How many complete oscillations can this device or moving object make in only 1 second? It's called its frequency. Frequency, the number of complete oscillations divided by time, while periodic time is the time taken divided by number of complete oscillations. They are inversed. Frequency equals number of complete oscillations over time taken by seconds, not minutes, not hours. Okay, problem. If the time taken by an oscillating body to make 600 complete oscillations is 2 minutes, we have to convert 2 minutes into 120 seconds. Then calculate the frequency by applying the rule. Frequency equals number of complete oscillations over time. 600 complete oscillations over time. 2 minutes means 120 seconds. 5 hertz. What's meant by hertz? The measuring unit of frequency. Every physical quantity has a measuring unit. For example, mass is measured by kilogram. Weight is measured by Newton. Distance is measured by meter. Amplitude is measured by meters. Frequency is measured by hertz. The measuring unit of frequency is hertz. I have 2 devices, and in 5 seconds, for example, the first one, device A, made all these complete oscillations, and the device B made only 2 complete oscillations. So device A has more frequency than device B. Device A has higher frequency than B. Give reason: because it made more complete oscillations in the same time than B. Comparison between frequency and periodic time. It's very important. Frequency equals the number of complete oscillations made by oscillating body over the time taken to make these complete oscillations. Periodic time, the time taken or the total time divided by the number of complete oscillations. Frequency equals 1 over periodic time. What's meant by this rule? If I have periodic time equals 5, so the frequency is 1 over 5. It's rule, okay? Periodic time equals 1 over frequency. If the frequency is 4 hertz, so the periodic time is 1 over 4 seconds. It's measured by hertz, it's measured by seconds. If the periodic time is 5 seconds, so the frequency equals 1 over periodic time, 1 over 5 hertz. If the frequency is 0.25 hertz, so the periodic time equals 1 over 0.25 quarter equals 4 seconds. And thank you for listening. I hope you understood it. Thank you.